Right, day 15 notes. The objective, analytically find the first derivative of a polynomial sine or cosine function and use it, meaning use the first derivative, to find intervals of increasing, decreasing, and relative maximum and minimums for the graphs of the original function. So on page 1, we're going to make connections between an original function and its derivative for both, in the whole section, polynomial and trig functions. Okay, so let's take a look at this first graph. Okay, so as we look at these connections, on the left side of this table is the derivative, and on the right side is the original function. So, hey, when is the derivative equal to 0? Well, that's when our original function had a horizontal tangent line, for example, either a relative max or a relative min, again, providing the original function is a polynomial function. Okay, so when is the derivative greater than 0? What does that mean? It means greater than 0 is positive, less than 0 is negative. Well, when the derivative is positive, the original function was increasing. Think about that. The derivative is slopes. So if the slopes of the original function are increasing, then um, if the, excuse me, the original function is increasing, then the slopes are all positive, and vice versa. If the derivative was negative, that means the original function was decreasing. So if my graph is going down, that means all the slopes are negative, which is what the value of the derivative is. All right, what happens next here when my derivative changes from positive to negative? Well, that means it's going to go from increasing to decreasing, positive to negative, increasing to decreasing. And if I was increasing and then I start decreasing, then I'm going to have a relative maximum. And again, vice versa, as I change from negative to positive, that means my original function was going from a decreasing function to an increasing function, which now tells me at that value there's a relative minimum. And we're going to start looking at some graphs and trying to see what we can get. All right, let's do that down bottom here. All right, a little tricky here. The graph on the left is the original function f of x, and what we're going to do is try to make the derivative, the graph of the derivative, f prime of x. Okay, so let's start up top. When the when I have these relative maxes and relative mins here, I'm trying to find what's the slope. Slope is 0, slope is 0, slope is 0. So let's look what that means. So when x is negative 1, 2, 3, 4, when x is negative 4, the slope is 0. So that means my derivative is 0. When x is 1, slope is 0. When x is 1, 2, 3, 4, 5, slope is 0. So hey, I have 3 zeros in this graph. Okay, so let's take from this point where x equals negative 4 and let's look to the left of it. So from negative infinity to that negative 4 value, the slopes here are all positive. All right, so that means my derivative must be positive. So from here up, and again, I don't know exactly where it goes, but that has to be positive. Now let's look from that negative 4 to positive 1. What's going on here? All my slopes here are negative. Oh, let me get on this side. So all those slopes are negative. Since it's decreasing, the slopes are negative. So, and that again is from negative 4 to positive 1. And I could be even more specific and I could find some values, but I just know it's negative. So it's got to, from negative 4 to 1, it's got to stay in the negative and it's going to end up going to 0 somewhere over there. And now let's check from positive 1 all the way up to positive 5. The original function is increasing, which tells me all my slopes are positive. So if I look at all these tangent lines, these are all positive. So, and again, I'm not too worried about what value they go to, but so they're up here above the x-axis. I could go way up, but again, this is just a possible graph because someone might say, hey, I felt it went up higher, and that's fine. And then lastly, as we look here from when x is positive 5 all the way to infinity, the original function is decreasing, which means all these slopes are negative. So, and I don't necessarily know what exactly those values are, but it's going to go something like that. So just from looking at the graph, we don't know what the actual function is. and I can come up with what a possible graph of the derivative is. Something I want you to start thinking about. Hey, if I have one, two, three terms, we learned that the the minimum it could be would be a degree 4 quartic function. It doesn't matter what that is. Well, if that's degree 4, this has two terms. This looks like it would be something degree 3, just to keep in the back of our mind. All right, next page, we're given a graph of the function, and we want to answer some questions about the derivative. So first of all, it says approximate. Whenever it's saying approximate, we're going to use the slope of the secant line. So the derivative at 4, so I'm going to try to find the slope of the secant line, and I'm going to use the points at 3 and 5. So the slope of the secant line passing through 3, -1, and 5, 4. So what I'm doing here is I'm using this point right here and this point right here, and that's going to be a secant line, and that's going to help me figure out what this tangent line is. Again, it's approximation, it's not exact. All right, and so we use slope formula, change in y over change in x, and we get 5/2. Question 2, at what values of x is the derivative equal to 0? Justify your answer. Well, I know if the derivative is 0, then I have to be at a relative max or a relative min. Here's a relative max, here's a relative min, here's a relative max. So this is when x equals -4, this when x equals 1, and this when x equals 5. Number 3, on what intervals is the derivative less than 0? So remember, the derivative is less than 0. The derivative is negative when the original function is decreasing. So from this point to here, I am decreasing. So that's from -4 to 1, and open because it's not including that because it's going to be at 0 there and 0 here. And then again, from 5 to positive infinity. Same information we used before. This is more formally defined on how to use the information on how to graph the derivative that we did on the first page. So these are the questions we'd go through and ask ourselves. Okay, number 4, in what open interval is the derivative greater than 0? Justify your answer. So the derivative is greater than 0, then f of x should be, the original function should be increasing. When does the original function increase? Hey, from -infinity, it's going to increase all the way up to that 0. Oops, sorry. So from -infinity all the way up to -4. And then there's another time when it increases, that's from 1 to 5. Okay, and we have those intervals written right there. Okay, now let's answer question 5 and 6. It's another way to talk about what we did on 3 and 4. So at what value of x does the derivative go from being below the x-axis to above the x-axis? And this is about the derivative. So in order to go from below to above, I'm going to go from negative to positive. Okay, and it looks like, hey, it starts -4 all the way to 1, and then over here at 1, it begins being positive. So it looks like it's going to go from negative to positive at x equals 1, and then down bottom here, it says at what value of x does f of x go from being um, above the x-axis to below the x-axis. So that's when the derivative is positive, and I should write that down. That's the derivative goes from negative to positive, and here the derivative is going to go from positive to negative, and we're going to use this a little more formally on our next example. So it goes from positive to negative. So where was it positive? Hey, it was positive -infinity to -4, and then it begins being negative at -4. So hey, at x equals -4. And then we just said, hey, from -4 to 1, it became being um, negative again, and that's where it went from negative to positive at 1. And then um, at 5, what does it do at 5? It goes from being positive at 5, and then again, it goes to being negative. So we're at positive to negative, so there's 5. Those are our two values. And let's go back to our previous graph that we did pretty quickly, and let's look at, so hey, negative to positive at x equals 1. Right down here, sorry. +1, it goes from negative to positive. And then over here at -4, it goes from positive to negative, and at 5, it goes from positive to negative. So what does that tell us? That tells us where our zeros are.